Hey everyone, and welcome back to the channel. Today we are diving into one of the most fundamental and surprisingly practical topics in algebra, quadratic equations. Don't let the name intimidate you. By the end of this video, you will not only understand what they are, but why they are so important in the real world and exactly how to solve them. We will break down the concepts, walk through examples, and even give you a chance to practice. So, let's start with the basics. What exactly is a quadratic equation? In simple terms, it's an equation that can be rearranged into the standard form you see here. That is ax square plus bx plus c is equal to 0. Let's break down what these letters mean. A, b and c are known values. A cannot be 0, otherwise it wouldn't be quadratic. X is the unknown variable we want to solve for. The x square term is what makes it quadratic. It is the highest power of x. The key identifier is that x is raised to the power 2. The x square term. If the highest power of x is 2, it's a quadratic equation. If it was just x, it would be linear. Simple as. There are a few examples of what a quadratic equation looks like and some non-examples just so you can see the difference. So, why do we need these equations? Quadratic equations are important because they model curves and help us find maximum highest or minimum lowest values in real world scenarios. These are the three main areas where ax square plus bx plus c is equal to 0 is used. Tracking motion in physics, designing structures in engineering, and finding optimal values in business. They truly are everywhere. Before we start solving, we need to clarify what we are actually looking for. When we solve a quadratic equation, we are looking for its roots or zeros. These are the values of x that make the entire equation to 0. These roots fall into three categories, which we will determine using the discriminant later. So while the discriminant gives us three outcomes, the complex outcome can be further detailed into two forms. First, two real roots. These are the standard numbers you see when the parabola crosses the x-axis twice. Second, single repeated roots. This happens when the two roots are the same value. Graphically, the parabola just touches the x-axis once at its vertex. Third, two complex roots. This is where the numbers involve the imaginary unit iota. Crucially, if you have one complex root, say a plus ib, the second root is always its conjugate, a minus ib. Fourth, a special case is pure imaginary roots, like plus minus bi. These occur when a is 0, meaning the roots are just the conjugate imaginary parts. Alright, now how do we actually solve them? Solving a quadratic equation means finding the value or values of x that make the equation true. These values are also called the roots or zeros of the equation. There are a few methods to solve quadratic equations: factoring, completing the square, and using the quadratic formula. While factoring is quick for simple equations and completing the square is fundamental to understanding, the quadratic formula is your universal root. First, there is factoring. This is the fastest way, but only works easily when the equation's numbers are simple. Let's look at x square plus 7x plus 10 is equal to 0. We need two numbers that multiply to 10 and add up to 7. Those numbers are 5 and 2. We set each factor to 0 to find the roots. X plus 5 is equal to 0 gives x is equal to minus 5, and x plus 2 is equal to 0 gives x is equal to minus 2. So factoring is great when you can easily spot these numbers. Next, we have completing the square. This method is the foundation for the quadratic formula itself, and it always works, though it can get messy. Let's use the equation x square plus 6x minus 7 is equal to 0. First, move the constant term to the right side. X square plus 6x is equal to 7. Now we complete the square by taking half of the middle term, squaring it, and adding it to both sides. Take the square root of both sides, remembering the plus minus sign, then solve for x. It's a powerful method, but you can see it takes a few steps. As you can see, these methods have their limitations or can be time consuming. That's why we focus on the quadratic formula today, because it always works with any numbers you give. Here it is. the universal solution to all quadratics. Remember, the a, b and c are taken directly from your standard form equation. The plus or minus sign is why we often get two solutions for x. Now, let's talk about the most important part under the square root, the discriminant, that is b square minus 4ac. This single value tells us exactly how many solutions we will find before we even finish the formula. Case 1 d is greater than 0. If the discriminant is greater than 0, a positive number, we will get a positive square root. This means the plus minus sign gives us two distinct real solutions. Case 2 d is equal to 0. If the discriminant is equal to 0, the square root is 0. Since plus minus 0 doesn't change anything, we end up with only one real solution, sometimes called repeated root. Case 3, d is less than 0. If the discriminant is less than 0, a negative number, we are trying to take the square root of a negative number. Therefore, there is no real solutions. Let's use the formula on our example 2x square plus 5x plus 3 is equal to 0. Step 1. Identify A, B, C coefficients. A is equal to 2, B is equal to 5, C is equal to 3. Step 2. Calculate the determinant first. We get 1. Since 1 is greater than 0, we know we will get two real solutions. Step 3. Plug the values into the full formula. We split into the plus path and the minus path. Our solutions are x is equal to minus 1 and x is equal to minus 3 by 2. It's your turn. Pause the video and solve this equation. Don't forget to check the determinant first. The final answers are x is equal to 1 and x is equal to minus 5. Great job if you got that right. We did it. We now know the three ways to solve quadratic equations and most importantly, how to use the quadratic formula and discriminant to predict your number of solutions. If this video helped you, please hit the like button and subscribe for more math breakdowns. Leave a comment below if you have any questions or want to share your favorite method. Thanks for watching and I will see you in the next video.